The next speaker is Rob Huff from the CSIRO, and the title of the talk is Exploration Data, Analytics, Uncertainty, and Security.
Thanks very much, Dave, and thanks to Dave and Richard for inviting me to be able to come and talk to you today. It's a great pleasure to be at this meeting, and there's a number of my CSIRO colleagues here and featured in a range of presentations. For those who don't know, CSIRO is the national science body in Australia, the national research organisation, with about 5,000 people across a whole range of disciplines. And we're lucky enough that in mineral resources there's about 280 people working across the value chain. And in exploration and mining geoscience, the bit that I look after, we've got about 75 people. But interestingly for this talk, I thought I'd do something a little bit different and talk about some of our work around thinking about digital disruption or data analytics. And CSIRO has an entity within it called Data 61, which is a relatively new body of about 450 data analytics experts, mathematicians, software engineers, etc. So we're very much interested in pulling from that community of how they can support us in our exploration geoscience and mining geoscience and help us solve some of our challenges. We've heard around a range of technologies today, which is absolutely fantastic, which offers the opportunity of a plethora of new data that will be available for us to apply some smart methodologies. And obviously with supercomputing, cloud computing these days, that's less of a challenge than it once was in terms of being able to do quite fancy things with the data. So a range of collaborators involved with this. Very lucky to have a wonderful team of people working with us in CSIRO, and I certainly acknowledge them. So as Steve and a number of people have alluded to today, a big focus not just in Australia but internationally is around the cover challenge. I kind of describe it as our big science challenge. The astronomers talk about the square kilometre array and looking into deep space as their big science challenge, and our big science challenge is to have a microscope that looks down beneath our feet, not out into space, to try and see what is beneath our feet and to predict what's beneath our feet. And the cover itself is something that CSIRO has a long history of working on, and certainly around in situ regolith profiles, great success in terms of translating that to impact with the industry. What we're very interested in doing now is trying to develop that next generation of technology and approaches to really try and solve this challenge of exploring through cover. And certainly one of my take-home messages would be, and Ravi, my good friend as well as colleague, would say that the next challenge for us is to go into deeper covered terrains than we have done previously and develop that next generation toolkit. One of the things that's really fascinating around this is that when we actually look at the cover, we need to be better at characterizing the cover itself, both from a geophysics and from a geochemistry perspective when we're trying to deal with those deep cover challenges, and certainly landscape evolution through time, alteration, diagenesis, weathering of those sediments and cover sediments is a very important thing for us to try and constrain. And I take an example from the oil industry here. CSIRO has just launched a future science platform, which is a strategic push for us in deep earth imaging across minerals, energy, and water, trying to generate the next generation of algorithms and technology, not hardware, but very much focused on software, modeling, and simulation around subsurface imaging. I spent last week at the AAPG SEG meeting in London trying to learn from the oil and gas sector around what is the current cutting edge in terms of simulation. And it's really interesting, and we've actually been involved in some of those developments from our energy group. And this is an example of one. GIFI is a tool that's commercialized with a company called Icon that was developed in partnership with CSIRO around subsurface prediction of a given sedimentary facies within a sedimentary pile. So it's an inversion, yes, it's basically a facies inversion that in this case is looking to try and predict gas sand with uncertainty around it within a sedimentary basin off the northwest shelf of Australia, with some success in this example. I liken this to the kind of thing that we need to do with AEM data sets, and we have started to do them in water space, but also in mineral exploration space around predicting horizons within that cover that might be targets for sampling for those kind of subsurface prospecting tools we just heard Richard so eloquently talk about. exploration through cover is one major challenge that we're trying to address, and some of that predictive capability is important there. But also ore body knowledge. So when we get close to the mine, where it's in a near mine environment or in the mine, there is a great deal of technology starting to be deployed, which is delivering us new data sets. CoreScan done some great presentations here showing their spectral imaging capability, and we've been working with some of those data streams, producing machine learning approaches to those data streams to actually start to try and make predictions from those data. Certainly relevant to upscaling that data into an ore body knowledge plan, feeding through that data through from not just from the exploration program, but to the implications through the resource model and to the mine planning, and of course through to beneficiation. So in this case, what we're doing is we've built what we call the Rosetta Stone, which is a predictive analytics platform, effectively, where you build a reference library of representative samples. We do the characterization, and that can not just be using spectral imaging, could be XRF imaging, could be petrophysics data, could be lab-based information. We're building a drill core laboratory in Perth to test some of these platforms with a $3 million commitment on our part to have those technologies to be able to integrate the data sets in a platform like this. But then once you've got that library of canonical samples and data, you can start to use that to learn in time as you start to get the data streams, and also hopefully to start to make predictions, and the model improves as you go on. We've done this to quite good effect with an industry partner, where we've actually deployed this into an environment where we were looking at the data streams in an IOCG, where perhaps the real interest was the potential of chlorite to clog up the actual mill, rather than anything around exploration. But what came out through this is that when we look at these data streams, what you're seeing there is the black lines in that data are the actual assay data. On the left-hand side is the predicted label around the geological classification, and the red zones there are around the prediction around that, based on applying our machine learning approach. But what's really fascinating is that we started to actually be able to make fairly good predictions around things like grade, in this case copper and uranium, even though the spectral information wasn't actually providing direct data on that, but we were getting that as an effective proxy. But we've also got a measure of uncertainty around that data set as we go, which is of interest as well. Those kind of things are very interesting if we can move from being reactive in those kind of settings to actually being predictive as to what might happen, that might actually affect value within the system. Now, what's interesting about this is when you start building these engines, it's not just limiting to working on data streams like this. You can start thinking about it around smart drill programs, around building active sampling approaches to field sampling, and really I think that's where that kind of shift with our industry will come in the application of some of these methodologies. We've had a long history of actually being able to work with, particularly the geological surveys, of actually being able to pull data across boundaries together into single portals. So one of the things we realized very early on, that well before you can actually start to do data analytics, you actually have to be able to gather the data. You have to monitor data quality. That's very, very important. And you have to set some standards across different databases. So in one database you might have a gold called gold. In another it might be called AU. And you need to be able to have that data being interoperable and standardized at some level to be delivered into a single portal. Done that very effectively over the best part of 10 years with support of Ozscope, as part of recognizing that this is national research infrastructure in Australia as a data platform. And so once that data can come in from various sources, not just the geological surveys, but research projects can have data uploaded into this portal, you start to be able to have that data available to be able to apply things like analytics. And the example I've got up there is the virtual geophysics laboratory, which actually allows you to upload data, use some publicly available open source algorithms, inversion tools, and get a product back and be able to test research algorithms, I guess, in this kind of secure platform and see what you get back. CSIRO works quite a lot on megatrends and future scenarios, and I've put this up there because one of the things that comes up pretty strongly here, point 5, digital immersion, but also point 7 around great expectations. that with social license that are increasing pressure on our industry to do to be seen to be doing the right thing at a range of levels. You heard Barrick talk, give some fantastic talks around innovation, around the importance of recycling, blockchain, tracking gold, the quality of gold, etc., etc. And I think this holds true in terms of our industry and thinking about that kind of future. The reason I put this up also is because in not long ago, an exploration managers conference, the young people that were in the room said that they increasingly want to be able to data share across tenement boundaries to be able to do their exploration programs, and that was something that they were increasingly could consider that the future, that was a scenario that they would be very interested in a future scenario. And this conference is, if we're thinking about it in 10 years' time, what would it look like? The example that Richard showed around the footprints that have been seen around the Kalgoorlie goldfields. Can you imagine if you could see that right across a continent at multi-scales, multi-resolution? But what kind of tool do we have to actually make that available? So this is the conversation I've been having with Data 61 around blockchain technology and other platforms that they use to actually share data across the banking sector, where they take very, very secure data, where they want to preserve the integrity of the individual's data, but they want to produce different products from it. So this is something where you gather the data, you make sure it's standardized and it's secure, and then you can share the data and visualize the data. And the oil industry actually does this with their joint industry projects and their de-risking of regions where they share data and they share in the collection of data, and ultimately everybody wins. So this is an interesting place to watch around whether we can actually build a platform like this for the industry to be able to share secure data. Final takeaways really is that there is a future opportunity in the next few years to look at those kind of possibilities around smart planning, smart sampling, but also around application of machine learning. Those things are really incremental, but data sharing is a potential game shifter for our industry. Thanks very much.